Hey, good evening, everyone. Thanks for sticking around. My name is Eamon Mucklis. I'm a Senior Director at the New York City Transit MTA for Engineering and Construction.
Daniel Weiss with ARP. I'm the Associate Principal and Rail Systems Engineering Lead for the East.
I'm Josefa Irfani. I'm Director of Architecture for Gannett Fleming.
Everybody can hear well enough? All right.
Thank you for sticking around.
So, I've been working in the rail transit market in New York for 20-some years. The first time that resiliency really knocked on my door was here August 8th, 2007. There was a flash flood, which I studied geology undergrad, and I know what a flash flood is, and I didn't think it could happen in New York, but we have our own version. On the left side here is a couple of pictures on Hillside Avenue in Queens at 169th Street Station, where 7 of 8 rain gauges in New York recorded between 1 and 2.2 inches of rain in an hour, including proceeding over 2 hours, right? So the whole sewage system backed up, couldn't take this rainwater. And so, it just, to me, it was kind of shocking that would be happening here. So on the right side, you could see some of the passive protections that we designed at that time as a response to that storm. These bike racks that took up space on the street, but were upstands to keep more of the water in the street. And you could see at the top, maybe you could see, but I'll just tell you also. At the top step of that stair in the background at Franklin Street Station, we added an extra step, which is a big deal from an ADA standpoint. To be adding extra steps to stairs, it's hard to do. You get into all the railing issues, but it's necessary to prevent flash floodwater from getting into the station. And so that was like a big thing for me. But then different types of storms happen all the time.
All right, before I start talking about Sandy, you heard a lot about resiliency. You heard a lot about the buzzword resiliency and sustainability. I just want to tell you a story. So we're expecting a child this summer. I went to my wife and I told her I'm going to name the child Sandy. She was really mad. My first choice was actually flood, not even Sandy. All right, why I'm telling you this. So back in 2012, I moved to New York from Portsmouth, New Hampshire. Like everybody not from New York, when I moved, I wanted to rent one Times Square, New York, but that was taken. So my second choice was Shore Parkway, Brooklyn. Within a week, I was on a ground floor apartment, and there was 11 feet of water that came that day. So of course, I had to swim out of my apartment, thinking about the movie Jaws and all the sharks. And there was another movie where they have piranhas coming in one lake. So I've been doing flood resiliency work for the past 10 years. Right after Sandy, I got called to the MTA. So I saw the devastation firsthand. I still remember a day after swimming out of my apartment, looking around Brooklyn, then going to friends at Staten Island, also then working with the MTA on the Montague Tube. So you have all the stats about Superstorm Sandy is now 10 years ago, 17% of the city had flooded. At the time, all the airport, all the different transportation system were shut down. And I still didn't listen. They had all the warnings, but I did not listen to the warnings. And in Sandy, we created 2 departments, the recovery and the resiliency departments within New York City Transit. There was about $4 billion in damage, and we spent to date about $8 billion in both local and federal funds recovering from Sandy, as well as building resiliency measures, which we'll talk a little bit more throughout this case study. Then, of course, 2 years ago, and then even this year, we had a lot of rain events, and we have flash flooding happening around our system. Again, our system is prone to flooding because most of our infrastructure is below ground, especially in the city. We also have a lot of yards and a lot of shops that were built on, close to bodies of water. So we've seen a lot of flooding. Ida came, Hurricane Henry as well. We have casualties in the subway system as well as around the city. We have a lot of service interruption. So we had to go back and think about flash flooding, not only coastal flooding, which was our main target for the past few years. Some pictures from Hurricane Ida. You can see the impact underground. I'm sure everybody saw it on Twitter. Now it gets to you before it gets to us, because people will have it on Twitter or on social media.
I still don't know what that raft was doing.
To rescue people, I guess. All right, so since I said, I talked about how susceptible to climate change the New York subway system is, we had to think back in 2007 and 8, that was Hurricane Francis. They came up with the first flash flood in response. Then Sandy came, our heroic forces helped people during Sandy. Folks in the industry, whether from the consultant side contractor as well as the agency, were able to restore service as fast as possible, especially the Montague Tube. Then we started thinking about our capital resiliency project, how we can plan, design, construct resilience measures. That's where myself and a lot of folks, these gentlemen included, we came about 10 years ago, started putting our heads researching what is available in the market at the time, plan what we're going to do next, write the grants. We wrote a lot of grants to the FDA, the federal government, FEMA, to get those grants also to the state, and then started designing and then constructing. Till this day, we're constructing a lot of those measures. We also are working on process improvement. I heard, I think it was Tom Pendergrass in his panel, they were talking about how to hand over and then coming back. So a lot of the measures we installed, we are coming back from the capital side to the operators and the end user, telling them how to use this, making sure they are maintained and everything is being used. Also, we're using technology. They were talking in the previous one about digital and communication. We are digitizing the system. We are communicating to making sure that we have a system that we can have a notification and a fast response when there's an event. As I spoke, we have 277 underground stations, more than 400 entrances that actually for those stations underground, 15 under river tunnels, all of them seeing rehabilitation as well as resiliency measure. Post Sandy, we have 39 yards, terminal shops, and 850 miles of track. And we are currently continuing every year working on competitive resiliency and being prepared, looking at how we can respond to those kind of events, especially for flash flooding, which is more sudden. And it is changing as the neighborhoods gentrify, as the more impervious surfaces are being created around the city and outer boroughs, right? We are seeing more and more pockets of flash flooding, especially that our system actually is deeper than any other point in the city.
So with regards to this case study that we'll talk you through for improvements around Fan Plan 7204 on the Steinway Tube in Long Island City, which is shown on the right here. So there's really, I give a lot of credit to MTAC&D for their multi-layered approach. They're really organized about the way that they protect the system. So the first thing that they're always trying to do is they're tinkering with the SOPs, because this is a human approach. This is a human thing. Where are the customers going to be? How can you keep the customers away from a situation where you have perturbed operations? I was impressed with Hurricane Ida that there were not too many people in the system. There were not as many, photos of people surfing in the underpasses on Ida. I think it had to do with the way that they shut down operations, diverted trains, and things like that. So that, thinking about how the people interact with the system in a dangerous situation is something that MTAC&D is continuing to engage on. The other thing that was really important was, we thought about how to create near-term wins. What can we do to protect against next hurricane season? Not necessarily the full passive solution that could take a few years to do, but it was like, okay, what can we do now? Then, when the contractors took control of any site, they had to provide protection to the site, just like they would normally, like on a regular project, they might have to put up a fence, they might have to keep the site secure with security cameras, things like that. They owned the protection of the construction site for as long as the job went on, which I think was somewhat innovative. It is not always being followed around the city. It's something to think about as we wonder about how to protect the city in general. And then, really thinking through our solutions to make sure that that they're passive protections and that they provide the value of the passive protection is it's there before you even needed it, right? It doesn't require engagement when the storm is coming, when time is short. And so on the right side here, Fan Plant 7204, maybe those in the back can see a couple of rainbow lines. The green is what we considered to be grade level. A little bit above that, it's a little bit unclear if this fan plant actually got inundated by Sandy. But as we go up, you could see the light blue is category 1, the violet is category 2, and then a 3-foot buffer even higher, basically up to the top of the louvers, is the protection level for MTA C&D that's required by their design guidelines. So it's really progressive, looking forwards to where we could be in a few years.
So all of those ideas and thoughts and approaches to solving the problem had to be designed. So what I'm going to show you here is basically the blue circle, prior slide. The blue circle shows where this fan plant sits, and just for everybody's benefit, what does a fan plant do? It is generally located on either side of an underground tunnel. It's meant to evacuate air in a normal circumstance, or if there's a fire, there are heavy-duty fans inside these structures to exhaust smoke from the tunnel to make it safe.
And they're invariably close to the river, right? Because they are important to emergency egress in the underriver environment.
The upper right picture gives you an idea of the condition we found the fan plant. This is 7204. And the lower right shows the red rust-colored louvers are the existing fan plant exhaust system. So air comes up from the tunnel, it's pushed out the sidewall. So those louvers were located pretty close to grade. Obviously a problem given the design parameter of trying to design for 12 to 13-foot protection. This is a section. The blue represents the existing fan plant structure itself. The dashed lines indicate the movement of air through the system. And in front of the fan plant, so to the left of the picture, were 2 transformers. Everything in a transit system is redundant, okay? So in case power goes down, there's a secondary transformer that kicks in and offers, continues to support the system. So these are the types of areas that needed to be addressed. The transformers were originally outdoor. Part of the flood protection involved enclosing it with a flood-proof wall, and likewise the fan plant. In order to resolve the louver problem, we had to elevate or build an addition to the second floor of the fan plant. I should also point out that this fan plant had to remain in operation, another design constraint or parameter. So lots of kind of issues that needed to be addressed at the same time. And then the second story addition that was put on top of the transformers had to do with other resiliency protections that needed to be installed. This site needed a pump control room. They also wanted to provide dunnage for an emergency generator. Again, everything is about redundancy here in order to keep this, this building running. So this is the project. This is how we address some of the problems. So all the black granite that you see around the perimeter is the flood protection measure, and everything above is sort of the addition. So the transformers are now enclosed at the street level. The picture at the left shows the dunnage on top of the roof to allow for future generators to be put in. Any access points are flood-proof doors. So a whole host of products that needed to be investigated and researched and qualified before installation. So any of the new systems that we're putting in, as I mentioned, there's pump control systems being added to the second floor of the transformer. Any of those communications or any of those services that were going into the main building, we didn't want to introduce any new underground penetrations. Any underground penetration is an issue or that needs to be solved in terms of flood mitigation. So we created this cable bridge. The cable bridge also doubles as a sort of entryway into the fan plant. So again, this is another means of trying to think through the various elements that needed to be protected and not introduce new issues. And this is the final fan plant viewed in this neighborhood. So, you know, as Dan mentioned, you know, impervious surfaces are going on all over the city. I mean, this is, at the time of its construction, was a vacant site. At this point now, it's probably developed into additional buildings. So, you know, all of the measures, all of the future thinking in terms of protection needed to think of those possibilities as well.
You've done that now to all the fan plants?
I'm sorry?
Have you done that to all the fan plants now?
Anything that is close to the water and the floodplain.
Maybe the second floor?
Yeah.
Not
Well, no,
necessarily
not
every
all the
second floor, no. Some of them is just we build the building on top of the building.
Get the mic.
Sorry. Yeah, so some of them we actually built an envelope on top of the existing building while it's in operation. Some of them we built cast-in-place walls with the flood doors. So depending on the situation. But I might add to Josefa, any fan plant that we built, we took the opportunity to use to talk to the neighborhood. A lot of those, if you looked at the previous picture, it did not look aesthetically pleasing building before, and it was in Long Island City. It was built when Long Island City was industrial. Same with the North 7 fan plant that right now is in Williamsburg. A lot of those right now are in a very gentrified area, so we took the opportunity to actually innovate in terms of aesthetics and architecture.
But I think also like fan plants are probably the most not seen structure in the whole infrastructure network, and each one was designed and built turn of the century for the most part, and they're all unique in their own ways. So like one solution works here, might not work in another location.
All right, finally, we're going to talk about resiliency going forward. So I'll be talking a little bit about that. So we're actually, the good news is we're actually, New York, as everybody knows, a lot of, and you heard it from a lot of people, is a lot of agencies. Everybody kind of work in silos, but right now we're actually talking to these agencies, the different agencies, the DEP, DOT, also with the utility companies, coordinating with them. So we have, if you follow our projects in 207th Street Yard, we're increasing drainage, working with the DEP, same with Coney Island, also Westchester, which is coming next year. Also, we are working with DEP. We're looking at new solutions for flood, not only passive solutions such as the flood walls and the flood doors and the other stuff, but we're looking at more sustainable ones such as rain harvesting, installing rain tanks close to some of our assets. We're right now tackling a lot of our substations, installing rain tanks in the areas that we have in the real estate we have. We're also looking for new technologies. We talked about communication and technology. So we're looking at GIS systems where we are modeling our entire subway system, putting all our assets where they fall on the floodplain for coastal flooding, and also where they fall when where there is an intense rainstorm. We're partnering with brilliant engineers and vendors such as Dan and Josefa and other folks in the audience that we're partnering with them, seeking their expertise. And also we are developing backup systems. As Josefa mentioned, we have belts and suspenders for everything, and that goes for resiliency as well. So the fan plan that we presented not only had the walls and the flood doors, but also flood logs and flood panels in the critical rooms. So if one fails, the other could kick in. Final words?
Well, I think, you know, having worked for this many years with Eamon on projects like this and others, you know, and realizing how human-centered these approaches are, right? That those interagency boundaries, those differences between what agencies are doing and what their neighbor and partner agencies may or may not be doing, that's really the critical thing. Because the flood protections it's a vital system, right? So like, for example, with the signal system, the signal system is also a vital system. And, but, the control center and the engineers are practicing that vital system every day. And maybe every 10 or 20 years they have a crash or a derailment and they do their after action report. But that was on their day job, right? With resiliency improvements, the people who are responsible for protecting the system have a different day job, right? And then a unique storm comes up and is going to and requires them to do something that's like way beyond their day job that they may have been trained in the previous year or something like that. So it's really important to emphasize the training and the human relationships, and to make it easy for those people to do their jobs properly under stress. And so I think that's one of my main takeaways from this work stream, working with MTA C&D, that I think they do have their house in order, and I think it's, they're thinking really well about their assets, but it's really a team approach, and who else is on the team, and what do they got to do, and what are they supposed to be doing, right? And how can the city be working together, and who is that?
I think one of the big lessons, one last thing I'll mention is that when we were coming up with design solutions, again, these conceptual approaches work great on paper, but there was a specific incident during the design of this where, again, we're talking about a vertical column of water 15 foot high and dealing with that as a flood load on a wall. But then as we think about the site surrounding, the city sidewalks are not designed for that level of load. So we can protect this building all we want, apropos to, it's not just this site. It is a holistic, it's an ecosystem, right? And we need to make sure that we address design not as just a calculation on a piece of paper, but that this is a holistically thought system.
All right, rock and roll. Let's hit the bar.